So I'm going to talk about the Cognitive AI Community Group. And so this is basically focusing cognitive science as the interdisciplinary scientific study of the mind and its processes, and the belief that we can apply, there's a lot we can apply to AI based on decades of work in the cognitive sciences on the human mind. So the community group was launched in late 2019, and the chairs are myself and Ronald Reck. Community group reports, there's chunks and rules, plausible knowledge notation, and also on brand new and sort of still an early draft on the web neural network models. And there are also like a suite of demos, test suites, smart homes, smart factories, plausible reasoning, and Edge AI. And most of these links are on the on the GitHub page. So I've got 3 slides to show you here. One is on chunks and rules for modeling behavior, and this is inspired by work over many decades by John Anderson at CMU on ACTA as a kind of a model of human cognition. And so chunks and rules are just higher level syntax, simpler syntax than RDF, with chunks that are collections of properties that act on chunk rules which act on buffers, cognitive buffers, mimicking characteristics of human cognition and memory, including stochastic recall, spreading activation, and the forgetting curve. Kind of unlike most databases, it's more like human-like. And then we have rule conditions which match the buffers and the actions which fire immediately or invoke asynchronous operations. And there's a predefined suite of operations, cortical operations, plus application-defined extensions for controlling digital twins. The reasoning is decoupled from intent-based real-time control of external actions. For example, a robot arm laid on top of ROS, popular framework for robots. And this is excellent for concurrent threads of event-driven behavior using distributed models of context-sensitive perception of directed attention, which is very much inspired by how the human mind works. And then there have been recent extensions on supporting task delegation and synchronization across a swarm of cognitive agents, and with a paper last year. Then switching context from logical proof to rational arguments. In the real world, knowledge is usually uncertain, imprecise, context-sensitive, incomplete, inconsistent, and subject to change. But logic only works if perfect, unchanging knowledge. So goodbye logical proof, hello rational arguments for and against a proposition. Aristotle got there in ancient Greece with his guidelines for effective rhetoric, and arguments, as we well know, are used in courtrooms, businesses, and abused in politics. So PKN, or the plausible knowledge notation, is a simple syntax we've developed for expressing imperfect knowledge, inspired by work by Alan Collins and his colleagues in the 1980s. There's a web-based demo of the suite of premises, that shows a variety of argument forms. And PKN offers an opportunity to develop next-generation cognitive databases that complement large language models by making imperfect knowledge explicit. And my final slide. So this is talking about how we can democratize or simplify web AI with the web neural network models. So web neural networks is W3C's platform-neutral API for AI in the browser, and for acceleration with NPUs, GPUs, and CPUs. And it's designed for inference in mind, and the existing libraries are kind of huge and hard for newcomers. So to fill the gap, developed web neural network models, very simple high-level syntax and models that is passed to a directed acyclic graph and used to build executable WebNN graphs for inference testing and training. And then export to the MLIR format for cloud-based pre-training. And so the idea is Edge AI will complement much larger models in the cloud, as well as allowing for privacy-friendly personalization. Your personal data never leaves your browser. And there's two main aims for this. One is to support high-quality, accessible user experiences in the immersive web, allowing users to select how they interact with applications according to their personal preferences and capabilities. And low-latency multimodal models for video and audio that project your facial expressions onto your avatar, whilst allowing you to use spoken commands to convey your intents. And then a second model, which is for intent-based real-time full-body animation, so your avatar moves realistically while you're actually still slumped on your sofa in your living room. And another longer-term goal is to experiment with AI models that better mimic human cognition, true to the sense of the cognitive AI group. So sentient AI agents of continual learning, episodic memory, and emotional control. and to provide feedback on gaps in the web NN standard, for example, to enable faster recurrent networks. Now, if I've got a second, I can show, first of all, this is a demo for training. So if I just set it running. So you can see it, it's training a small model in the browser. And you can see this is just a log, and I can show you the code below. So there's a simple model, and it's essentially you set up some parameters and do train, and then you can do testing afterwards to evaluate how well the training went. And then we have a draft community group report.